Right, we'll move on to the next set. On box 23 now. We've got two box 23s just to make it more complicated. So we'll call box 23 other one 23A. I can't count, obviously. What is it? 28th, 14th to 15th, I think, today. Well, does it matter? No, it doesn't. So I think this is 3 Rotels. I just pulled the first one out of the box. Well, this doesn't look like a Rotel. Oh, no, 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 no. No, it's not. No. Oh, right. So this is... The same gentleman had the two Midland 4001s. It's the Cobra 21XFM. So we'll be probably spending 40 minutes on the retune and then an hour and a half changing the TX light on it. He's already forewarned me on that. And he's had this set for donkey's years and it's always worked beautifully. But we're going to go through it for him. He's now got a Cobra. He hasn't. This is the Cobra 21XFM. He's now got those two Midlands back. He's got the Harrier CBX. And there's this in another set in this box. I think it's a Midland 38, something like that. One of the 1990s ones. So good. So we'll do this on our test mic. So this is the only Cobra we ever had in the UK up to the rather poor performing CE multi-norm sets. PR 2794 sets, which came out in 1999. That 29 and that 25 that use the same chassis, which is usually DEF. So I don't know why people have some thing about Cobras, because this is the only mobile that they ever sent. And of course this is a Maxon 4E in disguise. I'll tell you what, we won't take any more screws out of it. Have I got a power lead on here? I haven't, have I? So I'm going to have to take the screws out just to get a crocodile clip on. As you know, we manufacture the correct power leads for these. You couldn't make it up. I had a comment on one of the customers who bought one of the power leads, which we put on eBay. Something about could do with thicker cable. Well, the pins, which obviously go into the housings that make up the connector, take a particular type of particular grade gauge of cable, and so you have to have different pins for different gauges of cable. And we've got the right pins, we've got the right gauge of cable, because these sets never draw even 1.5 amps. So if we're using cable this kind of, that will take 6 amps. So, you know, I really can't work some people out. I don't think it was a moan. Or was it? Anyway, we're not buying different pins in and different tooling and different, because it's different tooling for different pins. Why would anyone need thicker cable when the sets only draw 1.2 amps? I don't know. Right, so that's disconnected the speaker. I can't see any capacitors in there which have popped their clogs. These tend to be very reliable. And in view of not bothering to go into the next room, we'll use our crocodile clips leads, which are definitely going to be good for 2.5 amps. The power supply on this bench is 3 amp, or is it 2.5? We have another power supply for business radios, because the UK maximum is 25 watts. But some of the business radios we see have a 45 watt capability. We actually have to tune them up at 45 watts. So we do have an 18 amp power supply on this bench for when we're doing business radios. When we're doing CB radios, I want to see the digital ammeter that this particular power supply has, which is an LED meter. I just need to see that as part of my procedure. So that's why we use that, and all the bench power supplies are 3 amp, because there's nothing we ever do which is more than 2.5. Right, so channel 20, meter's lit up. He tells us it doesn't have a TX light working. He's absolutely right. How frustrating. So TX light not working, and we know, so that's not applicable unless you might have sent the mic. So actually I'll hold on, that was naughty. Meter lamp is fine. So let's have a look at what it's doing. So I'll switch picture in picture on when I select the right camera first, and we're on channel 20. Let's go on the low scale. It's more than 3 watts. It's 3.2. I'll pop it up to channel 40. 3.1. And on to channel 1. 3.1. So it's well balanced. Low power. Go back to channel 20. And it is 320 milliwatts. That might write itself when that's 4 watts, because it's going to be, that is 10 dB of there, isn't it? Exactly. Good. Right, transmit current 1.217. Deviation, wallow. It's only slightly high, 2.7 kilohertz. Pop that down a bit. We're not going to do the VCO. And the frequency, not far out at all, 27,79110. So it's not really noticeable, that. I'll just do that immediately, and that ticks one of the boxes. So, shall I turn it to the right or shall I turn it to the left? Let's turn it to the right today. It's going down. Turn it to the left then instead. It's going down. So it won't pull up any further. So in order for it to come spot on, it would need to have the crystal changed. And it's not far enough out to bother. So 27,79110. Crystal frequency dropping with age. So perhaps in another 10 years that'll need changing. Unless they're really under 79085, you know, I wouldn't be bothering. Right, we've discussed what the legal limit of that is in the past. So let's go through the transmitter I'll start on the receiver then. Do it a different way around today. So we'll go into transmit. Put the right thingy on. Got my soldering iron ready to melt the wax, and let's see what we can do. Checking we're still on channel 20. Yes. Very slight adjustment. There's wax in that one. Don't normally get that. I think they dripped it at the wax factory. So apart from that first one, they were all spot on. Make sure I've got the other tool handy. So that's now peaked. And you're supposed to drop it. It's just gone over the 4 watts. You're supposed to drop it with this one. There we go, bang on 4. Right, I'll just go look at the other channels. So channel 1, 4.1, channel 40, 3.9. So that's within 0.1, that's fine. And our new current is 1.145. So you'll notice it's now drawing less current, now it's being tuned, and we're getting nearly a watt more. So let's look at that low power now. 320 milliwatts, exactly the same. So we'll adjust that. So on the low power scale now, so it should be there. 400 milliwatt. So deviation, just pop that down. It's probably there now. Wallow, 1, 2, wallow. Yep, that's right. And then the meter. Helps if we go on that scale. So the meter now, it's that upper one, is now reading high, so there we go, that's now 4. Good. So that's the transmitter totally gone through. Good. That's all straightforward. So it was 4.5 watts and it's now 4 watts, so that's that done. Switches are fine. Right, first of all we'll just check the PA function. Testing 1 2, testing 1 2 1 2. Now we'll go over to the test instrument. I always say speaker, but it isn't, is it? It's the input to the test instrument. Right, let's just check we're still on frequency from earlier today. We are. So we're going to take a reading. Put this on the cyanide meter. And just drop that. It's not actually right, this on receive. It's not right at all. In fact, you could even say it was nasty. It's as if it's got RF gain, which it hasn't. 4.3. No. 1.123. Should really be under 1 microvolt on this type of set. 1.2. And for 20, if it'll even do it, it will. 2.2. Squelch, put it to full. .100 microvolts, exactly where it should be. And the sensitivity part, set the threshold. Show you the attenuator. We're on standby at 0.3 of a microvolt. Switch it back on. Still 100 microvolts. Yeah, there's definitely something wrong. And S9 is showing on the meter. Give you an accurate readout. It's 1 millivolt plus. No, it's 550 microvolts. That might not be adjustable. So the first thing we'll do is set this to signal generator to 100 microvolts, and let's look at the oscilloscope. See what the recovered audio is, because the detector can drift easily on this model. Only a little bit out. Better turn the squelch down. So we'll put the cyanide meter up. It has made all the difference though to the way this now feels. There's 4 dB, and let's go through the receiver. Tiny little improvement there. Tiny improvement there. Tiny improvement there. Ah, it's the IF that's out. And that's why the squelch isn't right. And that IF's out as well. Let's recheck them. Now I'll go back to the detector. I won't put the camera back on because you know what I'm looking for. No, there's no change there. So we'll now go back to the front end. I don't think this will have altered. Might be like chalk and cheese difference when he gets this back. So let's read off what we've now got. So for 12 dB cyanide, we've now got exactly 0.9 microvolts. So they're never the most sensitive sets, but they're always competent. For 10 dB, we've got 0.85 microvolts, and for 20, we've got 1.678, 1.85. Let's just see what we can hear it down to. That's 0.3, it's changed the tone. I could hear it down to about 0.25 of a microvolt. Right, so that squelch test again. Squelch to full. I'll put the attenuator back on the screen. 310. Now the squelch is too weak. Now it's too strong. It's possible that that's dirty. That's not right. That's now coming in at 100 microvolts, but it was before. Let's check the other end. So, signal generator to standby, set threshold. No, it's not right, this. About 10 microvolts, which is far too. So what's going wrong here? See where we are now. No. Well, folks, I'm going to come back to that because that's all that's left that's not right. I mean, it might take a lot of sorting out, but I want to sort this pesky transmit light out. So I'm going to we'll take the front off, take the power off, and pause the video. Okay, so back onto the record. I wasn't happy with the squelch on this. I've had Mr. Chippy go around for dry joints. He did find the filter wasn't 100% in, but it hasn't made any difference to the way the thing's performing. I have retuned around the IF because he's changed a couple of electrolytic capacitors. We don't normally have capacitor problems with these. They didn't show up as faulty. It has changed the tuning a little bit, and I think he's just changed too. But it doesn't have the squelch performance I would like. I think it's something like 8 microvolts. So we're just going to check once again. So with the squelch at full, let's see where we are. get an accurate reading for that. So it's opening at 80 microvolts as tight. So the reason I've dropped that to, normally have it to 100, is to give it better squelch action at the bottom end. If you remember, it was 100 microvolts. I'll just turn that down a bit. 100 microvolts to open at the most. Oh, I've gone and put it in the wrong box. 80 microvolts was the tight. So let's turn it down. So turn the signal generator to its lowest setting and then put it to standby and carefully set the threshold. Signal generator back on. It's 8 microvolts. So, you know, it's not good. Just correct that to 8. He's kind of thinking it's going to chop round. It isn't going to chop round scratchy corner. If it opens, it'll stay put because the hysteresis is great. I don't think it's faulty. It's just the way it is. There's this constant tolerance, isn't there, from one set to another? And I mean, the customer thinks this is a fantastic set, and other than the squelch action, it is. Now the other thing is the meter. It's not adjustable on this model, so now we've retuned it. We'll see what we get. We don't do modifications here. Later versions had the preset on the back of the meter. We just do not do things like that. I think Mr. Chippy's disconnected the meter. Yeah, we've got no meter happening. He's done the transmit switch. Sorry, transmit light. There we go. He hasn't disconnected it. It's just not where it should be. So let's see. Just put the squelch on. So transmit, we set. Let's put it to high power. That's still showing 4 watts, so that's excellent. And then on the signal meter, 1, 3, 10, 30, 100 microvolts. So it's a bit of a lazy needle. It is 300 microvolts for S9. So it was 550. So it greatly improved to 300. So that's fine. That's fine. So my only note here is squelch circuit slightly insensitive. TX LED replaced. Good. We'll put that back together. Before I put all the screws in, I will just check if he sent a mic with it. In which case we'll just check that the deviation is set right for that mic, because it can differ. So I think after this the next set's a Midland 38. I'll just put one case in the screw, one screw in the case, just so that it doesn't fall apart and short things out while we plug the aerial in. So one of the things we can now do is see whether the internal speaker works alright. There's no reason to doubt that. It's another thing to tick off on the list. It does. 19er Roger. Foreign interference. So as usual, we're not going to hear anybody. 19er Roger. No. Right, we're doing on the air test later on with that. And that'll do nicely. Thank you for watching the Cobra 21XFM from 1981. So that's the early version of that.